We're going to move on now to solving systems with inverse matrices. Now, the linear system consists of the same number of equations as variables, meaning that's going to be a square matrix. If this matrix is also non-singular, meaning that there is going to be an inverse, then we can solve the system using the technique in example 7. Now remember, you can only use this technique if you have square matrices. In your homework, there's going to be some where you get to choose the method that you want to prove it and solve it, but if it's not a square matrix, you can't use it. So here we go. What we want, matrix A times matrix X will equal matrix B. Well, matrix A will be 3, -2, -1, 1. Matrix X will be the matrix XY, and matrix B will be the matrix 0, 5. Now we can find the determinant of matrix A. We talked about that in 7.2. So the determinant of matrix A will be 3 minus -1 times -2, or 2, which is 1. Now in order to solve for matrix X, which is X and Y, X will equal A inverse times matrix B. Now the first few we're going to do by hand. So you'll see when we can't do it by hand anymore, we can do it in our calculator. So to find the inverse of matrix A, remember it's 1 over the determinant times, we're going to switch our A and our D value and take the opposite of B and C. So my inverse matrix will be 1, 2, 1, 3. This is A inverse. Now when we multiply that by matrix B, we're going to get a 2 by 1 matrix. This is a 2 by 2 matrix. This is a 2 by 1 matrix. So my answer will be the numbers that aren't circled. So that's going to be a 2 by 1 matrix. This will equal them. 1 times 0 is 0. 2 times 5 is 10. 1 times 0 is 0. 3 times 5 is 15. So my answer to this problem here is 10, 15. Or you can put your answer as an ordered pair. 10, 15. Now they're not always going to be this nice or this easy, but we still should be able to do these by hand because we are pre-calculus students. So again, let's write our matrices. 2, -3, 4, 1 times xy. That's going to equal -13, -5. Well, let's find our determinant of A. Determinant of matrix A will be 2 minus a -12, or 14. That means my inverse will look like this. Now the nice easy way we can do this, and I'll show you right now how to do this, makes it nice and simple. We're going to do, because X is going to equal A inverse times B, let's just write the inverse here without actually simplifying it. Times matrix B, which is -13, -5. So what we can do, we can multiply the two matrices and then divide everything by the scalar negative, or multiply it by -114. So we'll still have the 1/14 there. So I have 1 times -13, which is -13, 3 times -5, which is -15. -4 times -13 is 52. 2 times -5 is -10. Simplifying this further, we have 1/14 times negative, and that's going to be -28, and 42. You should see now that 1/14 of negative 28 is negative 2. 1/14 of 42 is 3. So there's my answer, negative 2, 3. Now, if you would have put the 1/14 in, it would have been much more difficult to do that, but you could have done it, you could have solved it out because you're all intelligent math people. Now, in examples 7 and 8, these are two instances of the following theorem. Let A be the coefficient matrix of a system of n linear equations in n variables given by A, x equals B, where x is the n by 1 matrix of variables, and B is the n by 1 matrix of numbers on the right-hand side of the equation. So basically our answers. If A inverse exists, then the system of equations has a unique solution, x equals A inverse times B. Now you have to remember, you need to find the determinant of matrix A, our coefficient matrix. So solving this system, 3, negative 3, 6, 1, negative 3, 10, negative 1, 3, negative 5, times our variable matrix will equal 20, 40, 30. First things first, let's put matrix A into our calculator. Go over, let's edit matrix A. Matrix A is a 3 by 3 matrix. Now just entering the numbers here. Now the big thing that we need to figure out, we need to see what the determinant of matrix A is. Because it's a 3 by 3, just do it in your calculator. The determinant of matrix A is negative 30. So that tells me that A inverse exists. So because A inverse exists, we can actually go and say x is equal to A inverse times B. So now what we have to do, we have to enter matrix B into our calculator. So let's edit matrix B. This is a 3 by 1 matrix. We have 20, 40, 30. So entering this in, I want matrix A inverse times matrix B. That gives me 18, 39 and a third, 14. So there we have it. You can also write your answer as 18, 39 and 1/3, 14. Moving on to B, again, let's write our augmented matrix. Let's not add the answer in there yet. We're going to multiply it by our variable matrix, and that's going to equal our answers. Again, let's put these into our calculator. Let's put matrix A into our calculator. So 3 by 3, so 2, negative 1 and 1, 1, 2, and negative 3, 3, negative 2, and 1. In matrix B, that's entered here, we have negative 6, so this is a 3 by 1, negative 6, 9, 3. First things first, let's find the determinant of matrix A to make sure that still the determinant of matrix A is negative 6. That means A inverse exists. So now we can go A inverse times B. So we end up getting 3, negative 12, negative 12. Which is not quite right. I think I put a matrix in wrong. Yep. There should be negative 3 here. Let's try that again. Negative 2, negative 5, 7. So x will equal A inverse times B, which is negative 2, negative 5, negative 7. Or your answer, negative 2, negative 5, negative 7.